All right, this is problem number 9. Rectangular plot of land is bounded on one side by a river, the other three sides by a single strand electric fence. With 800 meters of wire, what is the largest area you can enclose, and what are its dimensions? So let's start with a little bit of a picture here. So we've got a river. So we'll pretend over here is our river. And we're going to make a rectangular field. Does it say that? A rectangular plot of land. We're going to enclose that rectangular plot of land with a fence. So there's a rectangular plot. So we've got our river. So we're going to make a rectangular plot. We'll go this way, and this way. And this will be our plot of land. And we don't need any fencing over here because we've got the river. And whatever we're fencing into here, we're assuming that it's not going to swim away. So we look at our question. We want to zoom in. What is the largest area you can enclose? So again, we always zoom in on what are you going to maximize or minimize, and we want to maximize the area. So maybe I'll put a couple variables here. I'll note that this is x. I'll note this is y, and I guess I could put another x over here if I wanted, and I don't need another y over here because that's the river. Okay, area. Area is easy. It's a rectangle. It's x times y. And I look at that equation, and it looks nice, except there's two variables. So I need a secondary equation. And I notice in the problem they gave me 800 meters of wire. So my secondary equation, I've got 800 meters of wire. It goes here, it goes here, it goes here. So I've got an x plus a y plus an x for my wire. That'll take up my 800 meters. So 2x plus y equals 800. I look back at my original equation. Area equals x times y. Is it better to solve for x or y? Maybe slightly better to solve for y. Y is 800 minus 2x. And now I come back to my area equation. And I've got area equals x. I'll take out the y and put 800 minus 2x. Let's distribute. It looks like 800x minus 2x squared. Okay, that's my formula for area. I want to maximize the area because, again, the question is right here. What is the largest area? And to maximize or minimize anything, I take the derivative, and 800x becomes 800. 2x squared becomes 4x. And I set my derivative equal to 0 because I'm looking for critical points. It's a polynomial. It's defined everywhere, so the part where it's undefined doesn't make any sense. And I also consider endpoints. But when we think about the endpoints, x is going to be certainly greater than 0, because that wouldn't be a fence. And it's got to be less than 400, because I have an x here and an x here. And so there's no strict, it's not or equal to. It's certainly bounded between those two, but I don't have a strict endpoint I can sub in because it could be 399.9999999. So it's not a strict endpoint, but I certainly have a bound here between 0 and 400. Okay, back to my derivative. Sorry about that. Let's set it equal to 0 and solving that. And it looks like my one critical point is 200. Let's make a little chart with the first derivative. Extend that a little bit. And let's see what's going on here. So I've got x. I've got my first derivative. I've got only one critical point, 200. I'll go from 0 to 200. I'll go after 200 up to 400. And you might be thinking, why didn't you use the second derivative test? Certainly could have, but it doesn't hurt to try this. Between 0 and 200, how about 100? Sub the 100 in here. 4 times 100 is 400. 800 minus 400 is positive. So my function a is going to go increasing. Now come down here between 200 and 400. How about 300? Sub in 300. 4 times 300 is 1200. And my derivative here is negative. So I have found the max. Why is it a max? A prime switches at x equals 200. And it switches from positive to negative. So I have found the local max. Now, let's answer the question. What is the largest area? Look, our area is here. That's an x and a y. Or how about right there? So our area equals 800x minus 2x squared. Give ourselves a little more room. 800x minus 2x squared. X is 200. So our area will be 800 times 200. 2 times 200 squared. And we get 16 with 4 zeros, 160,000. 200 squared is 4 with 4 zeros, 40,000 times 2 is 80,000. So our maximum area is 80,000. What are the dimensions? Well, easy. X is 200, we know that. So x equals 200. And what does y equal? We'll come way back over here. Y is 800 minus 2x. So it's 800 minus 2 times 200. So our y equals 400. So we're leveraging the fact that we have a river and we're using more fence going back and forth because we don't need to use any over there. And then our x's are a little bit shorter because we had to use x twice. So we make it longer. I'm sorry, we make the y bigger. I don't know if that's longer or wider, but we make y bigger and x a little bit smaller. So largest area, 80,000 meters squared. We should put some units on that. And our dimensions are 200 meters by 400 meters. And that completes problem number 9.